Hello all, welcome to my course on methods of adhesion measurement theory and practice. We are at lecture 40 today and we are discussing about a thin layer of adhesive sandwiched between two parallel plates. So, here are the references. This particular reference you can see, which I am discussing and will be discussing in maybe another one lecture or so. So, this is the geometry that we are discussing about, in which we have got this elastic film that is sandwiched between two parallel plates, and we wrote the stress equilibrium relations in the last lecture, and also last lecture in terms of these deformations and gradients of deformations, and then we also discussed about this volume strain, and in fact we also used this dimensional analysis to identify the terms which are not so important, and we got rid of them, and finally we obtained this equation in which we integrated and we obtained this expression. Now, here as we discussed in the last lecture that we have b x and c of x, these are the integration constants, and this needs to be found out by considering the boundary conditions. So, I have said that this film remains bonded to this substrate at z is equal to 0. So, therefore, z is equal to 0, u will be equal to 0, and at z is equal to 1 there is no slip boundary condition. So, no slip means that this deformation of this film that will be same as the displacement of this plate. Remember, we have vertically pressing it, or in later on we will discuss that we are pulling it off. Okay. For now we are discussing this compression problem, and there is no horizontal displacement or x direction displacement, okay, of this top plate over here. As a result, this u here also is equal to 0. So, that is the condition, boundary condition that we have. So, if at z is equal to 0, u is equal to 0. So, then we can get that c of x will be equal to 0, and if z is equal to 1, okay, u is equal to 0, then we have 0 is equal to epsilon square by 1 minus 2 sigma, and this is z is equal to 1. Now, capital Z is equal to 1, remember why z is equal to 1, because z varies from 0 to h, and h is the characteristic quantity in the z direction. So, at z is equal to h, capital Z is equal to 1. Okay. So, I hope that is clear, and then this is 1 by 2 here, and this is del of a of x by del x plus b of x here. So, therefore, b of x is equal to minus of, this is half, this is epsilon by square by 1 minus 2 sigma, and this is del of a of x by del x, and this is what it is. So, I have derived it, and now we can substitute this expression, and we have finally this equation, right. Now, we need to find out the w, the expression for w, but for that we can make use of this compressibility relation or the volume strain. So, for that you need to find out del u by del x. So, let us do that. So, that is equal to epsilon square by 1 minus 2 sigma, and this is del square a of del x by del x square, and there it is z square minus z by 2. And remember that in compressibility relation is del u by del x plus del w by del z equal to minus p by k. So, here this is dimensionless, this is dimensionless, right, this is dimensionless, and here this is pressure dimension, this is pressure, and this is volume, this is k is the bulk modulus. So, these are dimensional quantities, but the ratio is dimensionless, right. So, this is bulk modulus. So, remember that capital P is the pressure. So, it has the dimension of Newton per meter square, and capital K is the bulk modulus. So, that also has a unit of Newton per meter square. So, the ratio is dimensionless, right, that is the way it is. So, del w by del z is equal to minus of p by k minus del u by del x. So, minus del u by del x is here epsilon square by 1 minus 2 sigma, and this is del square del of x by del x square, and z square minus 2 by 2. Now, 2 and my z are looking same, that is the problem, but that is okay. So, now this w we can find out by integrating. So, it is minus p by k into z minus this is epsilon square 1 minus 2 sigma, sigma is Poisson ratio by the way, and this is del square of a of x by del x square, and I have integrated with respect to z here. So, it is z square by 2, it will be z cube by 3 by 2. So, that is z cube by 6, z cube by 6 here minus this is z by 2, z square by 2, so z square by 4 here, z square by 4 here, plus let us say it is d of x, again integration with respect to z. So, it comes out to be d of x. So, I hope it is clear. So, z cube, so it is z cube by 3, 3 into 2 6, it is z, so z square by 2, z square, so 4, okay, correct, good, this is. And here again I have to use the boundary condition to kind of get of this value of this d of x. Remember that at z is equal to 0, this w is equal to 0, okay, that was the condition because the film remains strongly bonded to the bottom substrate, and so it is w is equal to 0 there, and this gives that d of x equal to 0. So, I have done all that. So, let us take this equation, okay. So, let us live with this. So, w is equal to this. So, now at z is equal to 1, okay, this w will be equal to capital delta, because capital delta is delta by h here. So, therefore, this, so we should get some idea of the a, that is what we are doing. So, delta is equal to minus of 1 upon this is 4 here 1 minus sigma into 1 minus 2 sigma square, and there it is del square of a of x by del of x square, and this is z is equal to 1. So, it is 1 by 3 minus this is 1 by 2 and minus a of x into 1. So, therefore, I have here this is 1 by 2 by 6 minus 3 by 6 minus 1 by 6, so it is 1 by 24. So, delta is equal to this is epsilon square, and this is 1 by 6 minus 2 by 6 minus 3 by 6, so minus 1 by, so minus plus 24 here, 24 into 1 minus sigma into 1 minus 2 sigma here, and this is del square of a of x by del x square, and minus this is a of x. So, finally, I will have del square a by del x square, I will write it del square a of x by del x square. So, it is minus this is 24 into 1 minus sigma by 1 minus 2 sigma by epsilon square into a of x, okay, that is equal to this is 24 into delta into 1 minus sigma by 1 minus 2 sigma by epsilon square, and yeah, like. So, here I term it as C1 and this as C2. So, this as this quantity as C1 and here this is at the whole thing as C2. So, therefore, this C2 by C1 by C1, okay, that is actually equal to delta, remember that is what I get. So, delta square a of x by del x square minus C1 into a of x is equal to C2, that is the equation in terms of a of x. So, this equation, okay, can be solved and we can solve this. So, let us try to do that. So, here let me do this, let me write it over here as del square by del x square a of x minus C1, this is A of x, and this is plus, this is C2 by C1 is equal to 0. So, here also I can write C2 by C1 because C2 by C1 is a constant. So, I did not need to worry about it. I hope this is correct. So, minus C1 and this is minus C2 this side, so right. So, therefore, this is now a homogeneous solution, homogeneous equation. So, therefore, now I can write that A of x plus C2 by C1, that should be equal to, now here the solution is terms of exponential functions and exponential function. So, this should be equal to, the C1 is there. So, C1 is the thing. So, now, so therefore, the solution will be some quantity into P1, yeah, P1 into exponential, and here it will be, let us say, square root of C1 into x plus P2 into exponential, it will be minus square root of C1 into x. I hope this is all right. If I double derive it, it will be P1, it will be C1 here, and exponential C1 square root of C1, and here it will be P2, it will be also be exponential minus square. I think it is fine. So, Ax, therefore, A of x will be equal to minus of C2 by C1 plus P1 exponential, this is square root of C1 into x plus P2 into exponential minus square root of C1 into x, yeah, like that. So, this is the solution of A of x, and then I find out what will be del of Ax by del square x. So, let us do that. So, this will be equal to P1 into square root of C1 e to the power, so it is exponential square root of C1 into x, and here it is P2 into square root of, or minus here. So, it should be minus P2 square root of C1, and here it is exponential minus square root of C1 into x, and double derive it. So, it will be P1 C1, this is exponential square root of C1 into x, and here it is plus again, this is P2 C1 exponential square root of minus C1 into x. So, C1 square root of C1 and then here C1, okay, this has been taken common, which makes sense, and then we have therefore this quantity like this, and so substitute in W is equal to this expression. So, W is equal to therefore minus 1 by 4 into 1 minus sigma into here epsilon square by 1 minus 2 sigma, and del square x by del x square. Let us see what did I get. It is C1 into, so it is C1 into P1 exponential square root of C1 into x plus P2 into exponential minus square root of C1 into x. So, this is this, and this should be multiplied by this is z cube by 3 minus z square by 2, and minus this should be equal to minus of C2 by C1 plus this is P1 exponential square root of C1 into x plus P2 exponential minus square root of C1 into x, like this. So, here we can actually further write it in a compact form, okay, we need to do that. So, into z here, so there is a, this is z here multiplied by z here. So, here it is compact form, right. So, plus C2 by C1 into z, and then plus, let us say, so here yeah, so this quantity and this quantity looks same. So, here to multiplied by C1 though. So, let me write it like this. This is minus here. So, let me write it minus, no problem. Minus this is P1 into exponential into square root of C1 into x plus P2 into exponential, it is minus square root of C1 into x into Okay, by the way, it is z here, this z we should not miss. So, here there is a z here. So, this is z and it is minus here, it is minus here. So, this is fine, it is plus. So, here it will be there is C1 here, and so this is C1 by C1 into epsilon square by 4 into 1 minus sigma by 1 minus 2 sigma into over here this is z cube by 3 minus z square by 2 like this. So, again let me just check. So, minus minus plus here. So, C21 into z. So, this term is fine, and then I have this term. So, in this term I have got a z here. So, therefore, this is z, it is minus here. So, it is minus, fine, and here this is minus here. So, this is minus and C1 is there. So, that is C1 into epsilon square. So, I have to write it here, I have written here, and this is z cube by 3 minus z square by 2 over here. Good, I think we are fine. So, it is like that. So, W we get this expression and this expression is here. There is a delta also somewhere. Oh, C2 by C1 is actually delta. So, that is what have been used here. So, here this is the final form. So, I have everything. So, delta into z minus fine, and u can be represented now can be estimated as written as u epsilon square by 1 minus 2 sigma, and here let us say it is square root of C1 into P1 into exponential square root of C1 into x minus P2 exponential minus square root of C1 into x into here it is z square minus z by 2. So, that is the way it is. So, now we need to estimate or you need to obtain this quantity P1 and P2, and then finally up to C1 and C2 already of course we know, but P1 and P2 need to obtain. Now, you see this expression whatever is there, this should be yeah. So, now at x is equal to 0, okay, at x is equal to 0 means that this is the plate film which is in between these two parallel plates, and x is equal to 0 over here. So, the deformation at x is equal to 0 should be equal to 0. So, u should be equal to 0 at x is equal to 0, okay, u should be 0 at x is equal to 0, okay, because of the symmetry. So, therefore, here I can write x is equal to 0 here, okay, for any z, right. So, therefore, this P1 should be equal to P2. So, at x is equal to 0, u is equal to 0. So, therefore, P1 should be equal to P2, therefore, u should be equal to epsilon square by 2 into 1 minus 2 sigma square root of C1, and this is P1 let us say, and this 2 will be using over here. So, it is exponential square root of C1x minus exponential. So, this is a sine hyperbolic function, okay. So, I will get rid of this 2 here and I will write it here sine hyperbolic square root of C1 into x and here as z square minus z. Similarly, W also be written as delta z. So, I will write it from here delta z minus this is P1, this will be cos hyperbolic function. So, let me write it here delta z minus this is half here and cos hyperbolic square root of C1 into x, and then there is a functional form of z there. So, I have divided by 2. So, I have to multiply it by 2. So, here it will be 2 into 2z cube minus 3z square plus z. So, no, it is not half, it should be 2 here, and this is 2z cube minus 3z square plus z, right. So, now deformation problem. Now, this volume strain at any location in the film. So, that is so now we need to obtain therefore del u by del x will obtain del u by del x. So, that will be equal to epsilon square by 1 minus 2 sigma square root of C1 into C1. So, it is clearly C1 actually here. So, it is C1 let us say, and this is cos hyperbolic of square root of C1 into x z square minus z. So, derivative of sine hyperbolic function is directly cos hyperbolic function, and del w by del z is equal to delta and minus 2 p1, and this is cos square root of c1 into x and del z, right. So, it is 6z minus 6z square minus 6z, okay, plus 1 should also be there, right. So, it is like that. So, this is del w by del z, and now you write this, use now this dimensionless Hurst expression and blah blah. So, you have this 6z square minus 6z plus 1. So, you add it up, and after adding it up you have this quantity. So, let us do that. So, we have got this 24, let us say w here. So, w delta here. So, delta is fine, and then I have got, let us say, plus p1 cos hyperbolic square root of c1 into x, and then I have 24. So, p1 go down. So, 24 into 1 minus sigma, 24 into 1 minus sigma into here z square minus z, and this is p1 into cos, so it is minus 2 into, it is 6z square minus 6z plus 1. It is like this. So, delta plus this is p1 cos hyperbolic square root of c1 into x. So, 24 into 1 minus z, 124 into z square minus z, minus here it is 2 into, it is 2. So, 2 into like this, okay. So, this is equal to minus of P by pressure, okay, by capital K. So, here it is like this. So, now the, how do I do this now? So, now we need to obtain this small p. So, that is that constant that had come. So, from the differential equation that you have to obtain. So, this is what it is. So, we have written it more compact from here. So, this is 2 has been taken out. So, if I take 2 out, let us do that. It will be 12 here, this is 2 I have taken out. So, it is 2 here, okay. So, here like that. So, it looks little simpler, that is it. And then I have this written it little bit more compact form. So, you can derive it, please do that, and then I will have this. This expression is valid for at any z, okay, that is the idea here. So, it is valid for any z. So, therefore, let us say at z is equal to 0, this is valid. So, therefore, okay, I say that, okay, this expression is valid for any z, and for it is valid at z is equal to 0, and so therefore, it is minus p by capital A, that is equal to delta plus 2 p1 cos of square root of c1 into x. This is minus 1 here, so it should be minus. So, I will write it here minus. So, here is like this. Now, what happens at capital X? So, x is equal to, see, this is the film, right, in between this parallel plate, this is the thickness here, and you are compressing this plate from the top, this is from the bottom, and this is x equal to 0, and this is, let us say, at x is equal to L by 2, x is equal to L by 2. So, now what happens is that at x is equal to L by 2, x is equal to L by 2, this pressure becomes atmospheric. So, it is 0. So, at x is equal to L by 2, this pressure, okay, whatever is there in the film capital P, that will be equal to 0, okay, or L by 2 or L minus L by 2. So, plus minus L by 2, okay. So, this end and this end, okay, pressure is 0 because it is exposed to atmosphere. Therefore, here I can get, here write it as delta is equal to 2 p1, and then it is cos square root of c1 into L by 2. So, I get an expression for p1 that way. So, delta minus 2 p1 is 0. So, therefore, here I get an expression for p1. So, p1 will come out to be delta by 2 square root of C1 by 2, and therefore, I will have, so instead of P1 I will substitute this P1 expression over here, and I will get delta minus delta cos hyperbolic square root of C1x divided by cos hyperbolic square root of C1 by 2 is equal to minus P by K here. So, I have an expression now for the pressure, okay, inside the film. So, that I have. So, now we can, using this expression we can estimate that for a given delta. So, delta, remember this delta here is the amount of deflection. So, that means the film is being compressed by between these two plates, right. So, delta will be what? So, that is the extent that it has been compressed. So, for that, okay, for that given delta, what is the amount of force that needs to be applied, that will be find out, okay, using this expression. I will take it up in the next class. For today I stop here. Thank you.